Hello everyone, hope everyone is doing well. The next test we are going to look into is what we call a paired difference test. Now, a paired difference test, this is looking at basically before and after of the same person. So what we did is, let's say there are 20 students in my class, so all these 20 students, they basically, let's say student 1, 2, 3, 4, all these students, 5, all the way to 20 students, they did some kind of, let's say, a mock test. And so after the test, they scored certain numbers. They scored. And then afterwards, I did some, let's say I did a review session. And then they took a very similar test again. And afterwards, they got, so I scored their test, or I graded their test, and this is what they got. Now the question is, like, did their scores improve? So or in other words, did this revision session help them get better? So that's why we call it paired, because it's each person's pair of scores that we're looking into, and it's the difference. So basically what we're going to do is find the test score minus the mock test scores, and then see, is there a statistical improvement or did no improvement between the mock test and the actual test. And so we can say, did the review session actually help us improve the tests of the students, of these 20 students? So let's look at an example and see how to calculate it. So we are going to use, again, we're going to assume we don't know the population standard deviation. So we're going to use a t-test here. And using the t-test, we're going to use a certain formula for that. So the first thing, actually, since we said it's a paired difference test, let's look at this example. Let's say that before a certain regimen change, this is what the maximum weight people could lift. There are 7 athletes training, and after that training, this is the maximum weight they could lift. So we would like to know, is there a difference in the maximum weight that they could lift? So from our case then, we want to see, if I wanted to write the null and alternate hypothesis, I would say that the null would be that the difference equals 0. There is no change. And the alternate, let's say I want to do a two-tailed test, and I will say the difference is not equal to 0. So how do we find the difference? We are going to calculate that. So let's say my difference is just the after training minus the before training. So this is my difference. And then the average difference is going to be these numbers. So on an average, I would say that these 7 athletes can lift 2.14 pounds more than, and this may be due to the training. So from here now we can, after we found our average, we can also find the standard deviation of the difference, and it would be of this difference, not of the pre and post numbers. And now the question is there an improvement? So how do we find that? We need to then calculate the t-stat. So our t-stat is going to be, so this is going to be our t-stat. Now, what is d? The d is the average difference that we have here. So I can also write this as d. And the standard deviation is just st bar. Mu d is basically whatever whatever we're testing. So I could also write my hypothesis is mu d equals 0, and the alternate is mu d is not equal to 0. And so I can find my averages, or basically I can calculate my t-stat. So the numerator, since mu d is 0, so I can just write them. The numerator is just the average, and the denominator, that will be the standard deviation, which we have here, divided by the square root of the number of observations we have. So we have 3, 6, 7 observations. And so this is what we end up getting. And then my t-stat is numerator divided by the denominator, so I get 4.21. So from here I can now calculate my critical value of t, which comes up to be, let's say I'm testing it at 0.05, and my degrees of freedom is 7 minus 1. So I get my number to be negative 2.44. So then from here, I can, if I draw my t distribution, I can see that my t-stat is 4.21, and my critical values are negative 2.44 and positive 2.44. But my t-stat is way out here near 4.21. So since it's in the non-rejection region, so we can say then we reject the null. This is doing it by hand. We can also do this using a pre-programmed package in Excel. Let me just copy this down here. And so let's say what I will do is I'll go to data. I'll go to data analysis. And then I can go to t-test paired to sample for means. And I'll click OK. And then I will select before training as my variable 1. I will select after training as my variable 2. Hypothesized mean difference is 0. I have labels. Now in this case, variable 1 was before training and after training, and variable 2 is after training. We can now find our difference, and this is what we find. If you notice, the t-stat here is negative. And the reason is they use x1 minus x2 as the difference. We use x2 minus x1. So if I actually switched it, if I put variable 1 as after training, variable 2 as before training, I would get this to be positive. But we get the same value. It's 4.214, and it's negative 4.214. This is my critical t. And so I compared those two numbers, and I can say that after training, the amount of weight that athletes can lift is more than the before training. So the average difference that we see that we calculate is 2.14. Now, what is the confidence interval of this difference? And the formula for the confidence interval, it's going to be very similar to what we did before. So it will be basically like the d I have, and then plus minus t. So this will be my confidence interval. Now, let me just bring these numbers over here so I can see what they are. And my n is 7. So then, and the t alpha over 2 is that of the critical t value at the critical value of the two-tailed test. So this is the number I'll be using. So then my value is, let's say my lower bound will be the average value minus the critical two-tailed test, the t-value, times the standard deviation divided by the square root of the number of observations, which is 7. So then we can write that here, and the upper bound will be, basically it will be the average plus the t-value we have times the standard deviation divided by the square root of 7. So from this number we can say then, based on these two numbers, we just make them into slightly smaller numbers. So we are 95% certain that the difference, or we can say the population difference, lies between 0.899 and 3.387. So this gives us the confidence interval. Hopefully this was helpful, and I will see you at a later video. Have a good day.